Welcome to the minerals video with Mrs. Lehnert. I'm Mrs. Lehnert. You should have with you your pen or pencil and your input page for minerals. The learning objectives for this video, a student will be able to describe how rocks and minerals are connected to each other, and student will be able to describe key characteristics and properties of minerals. So we should start off by talking, this is our first video of our rocks and minerals unit. So just kind of give you a little introduction to rocks and minerals. Rocks are made of many different minerals. Sometimes we will call those rocks polymineralic rocks because the word poly actually means many, and the word, or I should say the root poly, means many, right? And that's where that many part comes from. And then the root word monomineralic means one. And so sometimes rocks are made up of just one mineral. We call those rocks monomineralic. And sometimes we call those rocks that are made up of many different minerals polymineralic because they have many different minerals in them. So again, anything that is highlighted, you should be writing on your input page, and anything that is not highlighted should already be there. So the way I think of rocks and minerals, minerals are to rocks as words are to sentences. So if you think about words and sentences, words make up the sentences, minerals make up rocks. And we have a couple of pictures here at the bottom. These are a couple of minerals right here at the bottom. These are two of my favorite minerals. They're called mica. This one is a biotite mica, and this one is a muscovite mica. And you can have the penny right here, just so you can see how big these minerals are. Muscovite mica actually is used in a lot of makeup, eyeshadows, lip glosses, to make them sparkly and shiny and give them that shimmer, that frost appearance. So what they do is they break those minerals up and they turn them into kind of almost like a glittery substance. Muscovite mica has also been used before there were windows. Muscovite mica, they would peel them away and they would use them as windows because you could see through it. Kind of cool. And this rock right here is granite. You've probably seen granite countertops. Granite is used in a lot of buildings here in New York City, so if you see a pink and black, those minerals that are in there, that is granite. So let's kind of focus on minerals today. What is a mineral? Minerals need to be four things in order to be a mineral. The first one is that it has to be natural. It cannot be man-made. So anything that is man-made is not going to be considered a mineral. So for example, ice can be man-made. That is not a mineral. So it has to be a natural element. It has to be a solid. It cannot be a liquid or a gas. So anything that is in a solid form would be considered a mineral. So for example, water is not considered a mineral because it is not solid. It has to be inorganic. And in this case, what we mean by inorganic is that it's not living. So anything that is living, for example, something that is a tree or a plant or something like that, cannot be considered a mineral because it is living. So minerals are not living, they're inorganic. And then finally, minerals have what we call a distinct chemical makeup. They have a chemical formula, and so anything that does not have a chemical formula would not be considered a mineral. All right, so here is your first check for understanding. Your first question, is this a mineral? And not only do you want to choose yes or no, it is a mineral, you want to also give a piece of evidence from what you just took in your notes, identifying whether or not this is a mineral. So this is I'm not sure if you can tell from the picture there, this is kind of like a liquid that you're moving around. This person's moving around on their hand. You can see that it's kind of breaking apart a little bit. Some pieces are kind of in other places on their hand, and they can push it around on their hand. So it's actually something called, a nickname for it is called quicksilver. So hopefully you decided that that was not a mineral. We know that that's not a mineral because it is not a solid. It is technically a natural substance. It's inorganic, it's not living, and it is it has a distinct chemical makeup. It does have a chemical formula. That substance that you saw there is actually called mercury. It's the stuff that's inside of thermometers, or it used to be. It's actually very toxic, so that person hopefully had on some protective gear so they weren't breathing all of that stuff in. So the next thing we're going to talk about is the physical properties of minerals. So these are things that you can actually see. They're physically there. They're not chemical, they're physical. So things that we can actually look at and identify. And these physical properties of minerals are the things that we use to try to figure out what a mineral is. So if you go out in the field and you're trying to figure out, what is that mineral? These are the different tests that you can use to identify them. So the first one is color. That's the very obvious outer color of the mineral. You can see at the bottom here we have different pictures of minerals. And believe it or not, every single picture down here, every single mineral in these pictures is exactly the same mineral. The mineral down here is called quartz. And quartz. There we go. And so you can tell each of those pictures, each of those different samples of quartz are all different colors. So we say that color is not a reliable physical property of minerals, even though it's one of the very obvious ones that you can use to tell what a mineral is. You can have one mineral like quartz have many different colors. You can also have a lot of minerals be the same color. For example, this one right here is a clear version of quartz, but there are a lot of minerals that have that clear color. We just saw muscovite, which has like a clear whitish color. And so color is not a very reliable property. The next property, second property of minerals, is called the streak. Now the streak is the color of the mineral in powder form. And the way you get the powder from a mineral is that you rub the mineral on a streak plate. So these white porcelain plates right here, these are streak plates. And you take the mineral, and if you just drag it once across the streak plate, it will leave the color on the streak plate. It leaves that powder color on the streak plate, and that is the streak color. The third mineral property that we use to identify minerals is called luster. And luster, sometimes you may have heard the word lustrous or illustrious. That word comes from the word luster, which means how the mineral reflects light. So you can usually kind of move the mineral around, and if it looks, there are two types of luster. If it looks kind of metallic, if it has like a metal appearance to it, like the one on the left here, this one is a metallic luster, then we say it's metallic. And if it does not have a metallic appearance, like this one over here on the right, it is non-metallic. Now this one is kind of tricky. Sometimes they look shiny, and so you're always not really sure. It's like, well, is that shiny or is it just metallic? Because it can be metallic and it can be shiny, and if it's shiny, it could be metallic or non-metallic. So the way that I tell students is like a dead giveaway is that a metallic mineral will always leave a dark colored streak on the streak plate. And if it's a non-metallic mineral, it will leave a light colored streak on the streak plate. So that's a really easy way to tell the difference between these two types of luster. All right, so let's check your understanding with these two questions. The first question that will pop up is, what is the difference between streak and color? And so you will type your answer in. And then the second question that will pop up after you finish the first one is, how can you tell if a mineral is metallic or non-metallic? Again, you're going to be typing your answers in, and then feedback will pop up so you know if you are correct. So you just have to read the feedback. All right, so hopefully you did well on that check for understanding. And here's our fourth. We only have two left. There are 4 properties of minerals. So breakage is our fourth one. So minerals do break. You can drop them and they will break them. Please don't drop any of the minerals in our classroom because we want to be able to use them. But if you do break them, they can break in 2 different ways. One way is called cleavage, and that word actually comes from the word cleave. If you cleave something like a meat cleaver, for example, if you have taken a culinary class, you've probably used a meat cleaver, those really big knives. To cleave is to cut something. And cleavage in this case is how a mineral breaks in flat, predictable patterns due to the internal arrangement of the atoms. So they're breaking in ways that kind of look like they've been cut. So if you look here, that flat surface, it looks like it's been cut, right? Here's another flat surface right here. And so if you drop this mineral, or if you hit it with a hammer, for example, it's going to form these really flat surfaces. That's called cleavage. And the reason it does that is because if you were to look at the atoms inside of these minerals, they're lined up. This one on the left, for example, is lined up in a cubic shape, a cube. And so that's how they break, in these little cubes. The one on the right-hand side looks kind of like a cube, but it looks like it's kind of been shifted on the top, right? So it's kind of slanted, like a slanted cube. And so the mineral itself looks kind of slanted. It's not like a perfect cube, it's slanted. The top part is kind of shifted over to the right. And so this is all due to how those atoms are arranged inside of the mineral. Now, if the atoms are not lined up that way, then it's probably going to break in an uneven surface, like these minerals. And so we call that fracture. So fracture means that they break in uneven broken surfaces, whereas cleavage is where you have these nice flat surfaces. So if you were to break, for example, this one right here, this is actually a piece of quartz. Quartz does not break in these nice flat cleavage surfaces. It breaks in these uneven surfaces. And you can see where it's about ready to crack open, right? And they're just kind of all over the place. They're not in nice, even patterns. I think of this as like if you get a fracture in your bone, they just kind of fracture in on like a splintered. You can see this is like all splintered, all the heck, as opposed to like a nice clean break, right? And our fifth, and actually a really important property of minerals, physical property of minerals, it really helps us to identify minerals really easily, is called hardness. And hardness is actually whether or not you can scratch a mineral or if you can make a mineral scratch something else. So hardness is, can it scratch glass or can you scratch it with your fingernail? So either on the left-hand side there, can you get the mineral to scratch a piece of glass? And if it's really hard, then it's going to scratch the glass. Glass has a hardness, it's listed right here, of 5.5 out of 10. And if the mineral is going to scratch that glass, then it's harder than 5.5. And so that makes it a really easy way to identify what kind of mineral it is. Same thing with your fingernail. In this picture, this person is able to scratch the mineral with their fingernail. They've left a little scratch on that mineral. Your fingernail has a hardness of 2.5, at least a natural fingernail. I don't know about acrylic fingernails, but your regular fingernail has a hardness of 2.5. So if you can scratch that mineral, then that means your fingernail is harder and the mineral is softer or less than 2.5 out of 10. And so it's a pretty soft mineral if you can scratch it with your fingernail. And we always compare the mineral's hardness with each other. And there was a scientist that created a scale His name was Dr. Moh, M-O-H. And so this is Moh's hardness scale because he came up with this. And you can see on the scale on the right there that talc is at the top, and that one is the softest of all minerals. It has a hardness of 1. We'll actually get to see some talc in our classroom this year. And the hardest one is all the way at the bottom, which is diamond, and that has a hardness of 10. We will not see diamonds in the classroom this year. This is, by the way, not the same as breaking. So you can break the mineral, right? And it could still have a really, really high hardness, okay? So for example, steel, which is a metal that we use in building, it will actually shatter glass. You can take a piece of steel and break glass, but you cannot get steel to scratch a piece of glass. So glass has a hardness, glass is harder than steel, but it is actually not as strong in terms of breaking as steel. Okay, so there's a difference between hardness and breaking. So there are a couple of other properties that are sometimes really helpful in identifying minerals, but they're very specific to specific minerals. So for example, fluorescence. In this picture here in the upper right, these are minerals that are put under a black light, and a lot of minerals will actually glow in a specific color, and that will help you to identify them. So if you happen to have a black light with you, you can always identify specific minerals that way. There are also some minerals that have very specific properties, optical properties, like this one. This is calcite, and it has this property called double refraction, which means that you can see double when you look through calcite, just like in this picture. Some minerals are magnetic, and so they, if you have a magnet, you can stick a magnet on them and it will stick. Some minerals have a very specific taste. For example, this one down here is halite, and halite is what we use to create, actually, halite is salt. The table salt that you use every day to salt your food comes from a mineral called halite, and so obviously it tastes salty. And then there are also some minerals that react to chemicals. This one on the lower left there has some bubbles on it because somebody put a little drop of hydrochloric acid on it, and hydrochloric acid will dissolve calcite. And so when hydrochloric acid comes into contact with that mineral, it actually starts to bubble because it's actually dissolving that mineral so rapidly that it starts to fizz and bubble up. All right, here's another check for your understanding. These two questions will pop up, and then you just need to answer them separately. The first one that will pop up will be, what are the 2 different ways that minerals can break? And then the second question is, how can you tell if a mineral is harder than glass? So hopefully you did really well on those 2 questions. You will be identifying minerals this week using our BFF. Finally, you get to have your BFF this week. And so this is a sample page, page 16 in your BFF that you're going to be using to identify some minerals. And you're done. Don't forget to bring your notebook and your input page to class tomorrow to get a stamp, and make sure that you watch this video to the end and then click the little button so that way you get credit for completing the entire video. Thanks.